This is the test review video. Some of the problems I'm going to explain. Some of them I'm going to show you a graph. Okay, so I put this in the calculator in standard form. Here it is. This is where it crosses the x-axis at -4 and 3, and those are your solutions. Okay, for number 2, solve by the square root method, you have to isolate your squared term. So in order to isolate, we subtract the 8 on each side. Then we had x squared over 4. We multiply both sides by 4, and we get x squared is equal to -32. We take the square root of both sides. Now, this is a square root. So you cannot take the square root of a negative unless you get an imaginary answer. So this one, it is no solution. If you graph this one, it would not even cross the x-axis. So that's another indication. If it crosses the x-axis, there are solutions, and if it doesn't, it's no solution. Okay, so now let's try B. Okay, so here is here's B. So we have to isolate the square term, so we add 27 on each side. We come back and divide each side by 3, and now we have our square term by itself. We take the square root of both sides. So the square term comes out as x minus 4, and the square root of 9 is 3, plus or minus 3. Don't forget the plus or minus with square terms. So the first one is going to be x minus 4 plus 3, and the other one is going to be x minus 4 equals -3. So once we solve it, we get x is equal to 7 and x is equal to 1. And this little t thing down here is, I don't know, I messed up with the pen. So there you go, square root method. You should be able to do C and D. I wanted to change this one on the answer key on the original and make it -36. So go ahead and change that to -36 and solve it. If not, you're going to get a no solution, and I don't want that because we had that with number 2A. Alrighty, we're going to solve by the cube root method. Honestly, what I want you to do with this cube root method, get everything equal to 0, put it in the calculator, and see where it crosses the x-axis. For B, you're going to subtract 50 on each side so that it'll be in standard form. Put it in the calculator and see where it crosses the x-axis. And that's how you'll solve for cube root method. Solutions are just where it crosses the x-axis. Okay, so here's the vertex. It's always going to be the opposite of what's inside the parentheses. And then your k, so it's hk, 4, -8. How you find your x-intercept? You let y equal 0. So here we go. We add 8 to both sides. We have 8 is equal to 1/2. X minus 4 squared. So to get rid of the 1/2, we multiply both sides by 2, and we get 16. Now that we have our square term isolated, we take the square root of each side, which the square root of 16 is plus or minus 4, and that's equal to x minus 4. We add 4 to each side, and we got 4 plus 4, which is 8, and we have 4 minus 4, which is 0. So these are the x-intercepts. If you were to graph this in the calculator, you would see that it crossed at 8 and 0. That's x-intercept. Now we're going to go with y-intercept. Okay, so your y-intercept, you're going to let x equal 0. And you're going to simplify. Y is equal to 1/2 -4 squared, which is a positive 16. Half of 16 is 8, and 8 minus 8 is 0. So y is equal to 0. So your coordinate is 0, 0. Could you figure this out by graphing it? Absolutely. But this is how you do it algebraically. Okay, so now we're going to take the time to go over number 5. Number 5, the vertex is going to be the opposite of what's in parentheses, which is -2. That's your h, and here's your k. For the x-intercept, you let your y equal 0, and you're solving for x. So here we go. We add 1 to both sides. We're trying to isolate our squared term. We divide both sides by -3. We get the square root of a -1/3. We cannot take the square root of a negative. So guess what? There's no x-intercept. When you get a squared term with a negative under there, that means it's going to be imaginary, which means it does not cross the x-axis. So if you were to put this in your calculator, it would not touch the x-axis. That's an indication that there are no x-intercepts. So now we're going to find our y-intercept. Okay, so we're going to find the y-intercept. The reason I'm going over this is very important. A lot of points on the test. Knowing how to find the vertex, the x-intercepts, and the y-intercepts. I know you can find it graphically, but here's algebraically. We're looking for the y-intercept. We're going to let our x equal 0, and we're going to simplify. 2 squared is 4. Negative 3 times 4 is negative 12. Negative 12 and a negative 1 is negative 13. And if you graph this, you will see that it crossed the y-axis at 0, negative 13. Okay, so we did a lot of this information by hand. Now we're giving you the graph and you have to figure this out. So the axis of symmetry, that's the vertical line that splits it down the middle. So here it's going to be x is equal to 3. Is A positive or negative? It's positive because the ends are up. Nature of the roots, that just means what are the roots? What are the roots? Well, it touches in 2 places, so that means there are 2 real intercepts or 2 real roots. What's a possible equation? So this one, it's going over to the right 3 and down 5. So check it out over here. X is in the opposite direction. So it's x minus 3 squared minus 5. This shape is a U shape. We call it a parabola. The x-intercepts, you do not have to find them algebraically. You look at the graph. So it's 1, 0 and 5, 0. The y-intercept, you don't have to find it algebraically. You look at the graph and it's right here at 0, 4. Absolute max, there is no max because the ends keep going up and up. Absolute min, that's going to be your vertex here. So it's 3, negative 5. As x goes to negative infinity, that's the left of the graph. The ends are going up. So y will go to positive infinity, and as x goes to positive infinity, which is the right side of the graph, the end is up. So let's go over the reflection of the y-axis. So we can see the y-intercept, the reflection of the y-intercept. So it's right here at 4. So we need to figure out what this point is right here. Well, if we go over there, we already know that the height is going to be the same. So the height is definitely going to be 4. So our y value is going to be 4. But what is our x value? Well, the x value right here is 0. Our vertex of symmetry right here is 3. So we go from 0 to 3, and then we add 3 more, so that's 6. So it's always going to be 2 times your x value. So my x value for the vertex is 3, so 3 times 2 is 6. So my reflection is 6, 4. Make comments in the comment section in Google Classroom if you need more help with that. The domain is definitely going to be all real numbers, and your range is going to be centered around your absolute max or your absolute min. In this case, we don't have a max, but we do have a min. So the y values are going to be greater than the y value on the min, which is negative 5. Okay, so as we take a look at number 7, number 7 doesn't have numbers. So what? We're going to put some numbers there. We're going to make something up. It's negative 1, it's negative 2. I'm going to say this is negative 1, it's negative 2. So definitely you can see the axis of symmetry here. I guess I should have made that come over a little bit. Hold on. All right, so here you can see, let me go ahead and put a dotted line right here. This is a dotted line going down. So my axis of symmetry is going to be x is equal to negative 1. So this is your axis of symmetry. Okay. Is A positive? Over here, is A positive or negative? It's negative because it's going down. What is the nature of the roots? Well, there are no real roots. No real roots. Why? It doesn't even touch the x-axis. Let's give a possible equation. Let's build the possible equation from the vertex. So the vertex, let's say the vertex is negative 1, 1. So if we built our equation, it's down, so we put a negative in front. We'll do the opposite sign. Voila, there's a possible equation for that. The domain is going to be all real numbers. The range is going to be built around the absolute max or min, and it's going to be the y value. So y values are less than or equal to the y value of the min, max, and that's going to be y is less than or equal to -1. Same thing, you can figure out there are no x-intercepts. We can see the y-intercept. The y-intercept is going to be 0, -2, and put that in. See, did it ask us for the reflection? Okay, I don't see that. In behavior, we can see over here on the left, it's going to -infinity, and on the right, it's going to -infinity. So that's how you do those type of problems. Okay, here's the next part. This is major 2. Perform the indicated operation. So let me erase some of this. We can have some room to work. All right, so for this first one, we're adding. So I put the first polynomial at the top and the second one at the bottom, and just brought down and combined like terms, and voila, there you have it. This one is going to be a little bit more tricky. You're going to have to distribute this negative. So take a look at this. All right, so I wrote the first one at the top. I distributed the negative and made that -3x plus 2 combined like terms, and there you have it. You may need to push pause because I'm going fast through the video because I don't get much recording time. All right, so for this one, I sort of put 3x minus 2 in the front. I have blue right here because I took the 3x and I multiplied it by everything in the second set of parentheses and wrote it down here in blue. I went back and I took my -2. I did the same thing and I did underneath, distribute it with black. And I put my answers right here under it, and then I just added and combined like terms going down to get this final answer. Some of you like to do the box method. That's fine. You can do the box method. I like to distribute, so that's what I showed you. We're going to go to D and use synthetic division. Okay, so this next one we use synthetic division. So I wrote the coefficients down: 2, 3, -5, 1. The opposite of my divisor, which is 2, I brought down 2, multiply up, add down, multiply up, add down, multiply up, add the last together. So it's not a factor because it's a remainder. However, you still have to write out your final answer. These become now your new coefficients: 2x squared plus 7x plus 9, with a remainder of 19, which you write over the divisor. So you need to try E and F, and I will just write out the answers to E and F. Okay, so there's E, answer to E, and the answer to F. Okay, for this one, it says describe the transformations of this graph from the parent function. So anytime they say from, I always write the vertex of where they want me to come from and where I'm going to. So the parent function is 0, 0, and this function over here is 3, 1. So then I can just look at my number line. From 0 to 3, that's 3 units to the right. And from 0 to 1, that's my y values, my k, that's up 1. So it's easier if you write it from the vertex. So if I'm going from this, my vertex is -1, 4. And then my vertex to the one that's given is 3, 1. So if I'm on the number line and I go from -1 to 3, I went right 4 units. And if I'm at 4 on the y-axis and I go to 1, then I went down 3 units. So voila, there you go. Okay. So here it says give the equation of a graph that's dilated by a factor of 3. So my final answer is going to have a 3 in the front. And it needs to move 2 units to the left. Well, when I look at A, it's a squared here term. So the parent function is squared, which is quadratic. So I need to have my square in place. The parent function is at 0, 0. So if I go 2 units to the left, that's at -2. And we always do the opposite sign. So here's the equation to represent that. B, this is to the 3rd power, so it's cubic. So I got to make sure I have my 3rd power in place. I have my 3 because it's dilated a factor of 3. But now this is the tricky part. My pre-image is -1, 5, which means the vertex is actually 1, 5. And if I move 2 units to the left, then my 1 is actually -1. So when I put it into my equation, we always do the opposite. So it's x plus 1 to the 3rd power plus 5. This is the first half of the video.